All right, so we're looking at 6.1. Notice it asks us to deposit $2,000 in a savings account with annual percentage rate of 5.2%. So let's go to the notes so I can set us up with the formulas. So your simple interest formula, I equal to P times R times T, where P is your principal, so that means that's your deposit or your loan. R is your rate. Don't forget to convert that to a decimal before you calculate. And T is your time in years. Unless they say something different. Your sections I haven't seen say anything different, but you know, other applications could convert it from years to other things. But your time should be in years unless otherwise stated. And I is going to represent the interest earned. All right. So let me go ahead and erase this because you have different numbers. So we'll just do according to the numbers that we are given in this section. So we had $2,000 APR of 5.2%. And then the time, I believe, was 1 year. So it says compute the amount of interest you gain after 1 year. So that means 1 is your year. And you'll just plug it in. 2,000.052. And so don't forget to do that. And the year is 1.
I need to make sure that my P is in parentheses, or does it not? Yeah.
Oh, no, you don't necessarily have to. I mean, you didn't have to use parentheses at all if you wanted to do, you know, multiplication signs between all three.
Okay, either way, it's the same. Okay.
Mm-hmm. Yep. And so that should be $104. Oh, let me show you this one. All right, here it says compute. This is B, compute the amount of money in savings under savings account at the end of 1 year. Take the original value and add the interest. You know, if you want to know how much interest, you calculate the interest, but if you want to know how much is actually in the account, is what you deposited plus the interest. So that's all this is saying here. And it said this is equivalent by multiplying 2,000 by what factor? Basically, when you look at that 2,000, that represents 1 or 100%. And we already know that 5.2% is what, 0.052. So basically you could just write it as 1.052. So whatever that percentage is, you just put 1 in front of it as a decimal. So you had that 5.2, so that's 1.052. All right. Questions on that? So here they just want you to fill out the chart. We already calculated in 1 year. Should be 104. Add that 104 to 2,000. That's 2,104.
Okay.
Then the next year, you're beginning at 2,104. This is how they want you to do this chart. Because remember, it ended at 2,104 at the end of the first year. So in the beginning of the second year, you start with 2,104. Then you're going to put that 2,104. Go back to the notes. So then you're going to put 2,104 here and then run that calculation. 2,104 times point, my calculator.
Get out of my thing.
0.052 times 1. I got 109.40, and I think he wants to round it to, oh, no, round it to near cents, so 109. And plus 104. Oh, 13 points. And I don't think I was sharing my screen. All right. So we did 2104. That's where it started. And then we put it in the formula. You saw what we just did there. And that gave me 109.41. And you add the 109.41 to the 2104. That lets you know how much money would be in there at the end of the year too. And then you do the same thing. 113. I said 113, 2213.41. Then once again, you put it right here, 2213.41. Calculate this. That's the interest earned, then add it to the 2213.41. All right. So questions on that before we move to the next question? Make sure we're okay.
Okay, so far.
Share. So calculate the amount of money you'll have at the end of the indicated period. Assume you earn simple interest. Same thing. 3,800 times the 3.2% for 5 years.
Okay.
Same thing. So we'll move on to the next one. Okay, here's a different problem. So complete the table with the following investments. Show which shows the interest on over a 5-year period. So Suzanne deposits $5,000, simple interest 2.7%. Derek 5,000, compound interest, annual rate, compounded annual. Okay, so this is when we already talked about simple interest. Now we're looking at compound interest. So this is that formula. So this equation asks us to do both of them. So that's A equal to P times 1 plus R over N raised to the N times T power. So this right here is an exponent. N times T is an exponent. PR and T represents the same thing as it did in the last formula. And then N is the number of compounding periods per year. In other words, how many times are they going to apply the interest to your deposit or loan? And then A represents the future value. So how much is going to be in your account after so many years? Not just the interest, but how much is actually going to be in your account. So this calculates how much is actually going to be in the account, not just the interest. So if I wanted to know what the interest was, I would have to subtract. In other words, I is going to be equal to your A minus P. So if you have your future value and you remember how much it was that you deposited, subtract those and that will let you know how much interest you've actually earned in that account. All right. Scrolling up. Compounding periods per year, N. So they're going to give you keywords for N. A lot of times they don't give you the number. They just tell you how many times or how many, what the frequency of the compounding periods are without giving you a number. In other words, they will say annually. That means N is equal to 1. Semi-annually, N is equal to 2. Quarterly, 4 quarters in a dollar. Quarterly means 4 for N. Monthly is 12. Weekly is 52. And I hadn't seen daily yet, but that doesn't mean, in their pool of problems, you may not get daily. And that means 360 for Banker's Rule. Banker's Rule. Did we talk about that in class before? Might
Yeah,
have been.
like daily, weekly, monthly,
Okay.
yearly, something like
Okay.
that.
So we already talked about that. Okay, cool, cool, cool. Yeah, I thought that was familiar for this class.
How come it's not 365 days?
Well, 365, well, I've heard of two reasons why it is possibly the case.
Mhm.
They said that there are 5 major holidays that banks recognize. So that takes away the 5 days out of 360. Then I also saw that 360 is just an easier calculation than 365.
Gotcha.
So I think it's more so that latter versus it just being 5 major holidays. But who knows? Guess if you're really a banker and really into that, then you know exactly what it is. But
Right.
Yep. But it's called Banker's Rule. All right, so let's look at trying this out. Erase this stuff. I probably should have left that. I'll just write it again for next class. All right, so let me see. Let's go back to the screen. Matter of fact, I'll just take a picture. All right, so we have Suzanne, call her Susie. She's dealing with simple interest. And then Derek is dealing with compound interest. So that means we're going to use 2 different formulas for the both of them. Let's start off with what we know. Got 5,000 for both. I think the rate is the same for both. And compounded annually. So that means n is equal to 1. And we want to do it over a 5-year period, but we want to fill out this chart. So we're going to start 1 year at a time. All right. So let's look at Susie first. Yeah, I'll just do it like that. So for the first year, we're looking at the interest being 5,000 times 0.027 times 1. So it's 5,000 times 0.027. So that's 135. So that means the future value is always going to be with P plus I. So that's 5,000 plus 135. So that's 5,135. So let me look at the chart, make sure that's what we need. So annual interest 135, and then balance 5,135. Okay. And for Derek, go back. Ooh. So for him, we're looking at 5,000 times 1 plus 0.027 over 1 raised to the 1 times 1. So doing a recap on what these letters are for us. This is P, this is R, this is N, this is N, and this is T. So remember, it's compounded annually. That's why N is 1. The time is 1 year has passed, or after 1 year has passed. And then my rate was 0.027. So just lean on this formula that I gave you right here. So you may, for certain calculations, you can put it in just like that. So it just depends on the type of calculator that you have. Once
Right.
again, if you need help with your calculator, that'd be, you have to get with me outside of class time to make sure that you are straight.
Is there a way that the calculation, say that we put in the calculation, we do everything right, we put in everything right. Is there a way that it could still mark the answer wrong?
I don't know what you mean by putting it in right and then it mark it wrong.
I kind of get what you're saying, Ethan, because Math Lab's done that to me a couple times. If I'm like if the space is off just by like maybe an inch or something, it marks me as wrong. And I'm like, what? I just put that in. So it has to be like, I don't know.
So you accidentally hit the space bar.
Yeah. Like I did parentheses, and like had a equation.
Yeah, well, that's always an option.
Huh?
That's always an option. If you put a space in between a 5 and a 1, like that's, yeah, more than likely you're gonna mark that wrong because remember it's programmed to receive a certain type of answer.
Right.
Gotcha.
So if you put 5, if the answer is 51 and you put 5 space 1, yeah, it's going, because it's only a computer.
No, yeah, definitely. It was a longer one. It was like S equals 30 minus parentheses. Shit, I remember the whole thing. 40 times 1. Because I was like, wait, why is it not letting me? But like, it was just a little off, and I was like, okay. But I get what you're saying.
Yeah. Yeah, so you just have to be careful. But once again, especially when you're doing a test, when you can't do it over, if you were to do something like that and you let me know, I can award points accordingly, but I wouldn't know unless you go, you tell me, So yeah, I can go in there and put in answers and stuff, or put in credit, as necessary. But like I said, I just need you guys to let me know so I can go in and do so. All right, so that's the first row. The second row, it's a little, I don't want to say a little tricky, but you just got to make sure you know what you're doing. So let's go to the second row. And it really comes into when you start talking about Derek. It's a little different. So when we look at, go back to Suzanne, whatever her name is, Susan. I just call her Susan. So we're looking at year 2.
As you just said that, I remembered a Seinfeld episode with Elaine. It's Susie, not Suzanne, or whatever she said.
It's funny how things can trigger, somebody say one thing and it could trigger something else in your mind. Let me see. Do we want? No. Let's start. Let's just do 5,000.
Okay.
And then we have 0.027, and this time we're going to do year 2. So 5,000 times 0.027 times 2. That shouldn't be I. That should be I, not A. Excuse me. So, and that's going to be 270. And what you're going to notice is that for your simple interest is going to be pretty much consistent as you progress throughout your years. It's going to be that same 135 that's going to be added each time. Whoa, that's not how you do that. Come on, guy. All right. So as far as after year 2, it should be 5270. Now let's go back here. So notice what they're asking of us. The balance after year 1 was 5135, and it wants to know how much interest was earned going from the end of year 1 to the end of year 2. So we got to take that 5135. Let's go back. So next we will take that 5270 and minus 5135. Let me do it like this. We're gonna do year 2 balance minus year 1 balance. That was 5270 minus 5135. That should be 135. And like I said, it is not that big of a deal when we're looking at simple interest, but when we look at Derek's stuff, since he has compound interest, those numbers are going to be different. So when we go to our actual thing here, it should be 135 here, and we already knew that it was going to be 5270 from our calculations. All right, so the next one, looking at Derek. Derek year 2, we want to do was A equal to 5,000. We had 1 plus R, which is 27 over 2 years this time, raised to the 2, nope, not 2. No. 1 is down bottom, is 1 times 2. 2 years is right here. So that would be our calculation. And so throwing that in the calculator, we get 5273.65. If I'm not mistaken, they do want the decimal. No, they do not. So we're going to round to the nearest dollar. So make sure you pay attention to that, because certain problems want you to round to the nearest dollar, other problems want you to round to the nearest cent. So they are trying to make sure you pay attention to the directions. So,
Right.
So if we go back here, oh no. There you go. So we know 52, what was it, 74? Yeah, 5274 goes right here. So to figure out what goes here, that's when we subtract 5135 from the 5274. Might be 139.
What was? Can you scroll up to Susie, where it's year 1 minus year 2?
All right. All right. Was that good, sir?
Yeah, thank you.
Not a problem. So you can see that Derek is about to start earning money already, earning more money already, going from 135 to 139. And so you would keep that same pattern, to finish it out. So the next one will be year 3. We'll do that 5,000.027. Now I'll just do the setup. But you know what you need to do from there. Just follow that same pattern. So that would be year 3, and then for Derek, year 3. 5,000. 1 plus 0.027 over 1 raised to the 1 times 3. All right. So questions on how you will fill out that chart. All right. The next one, use the compound interest formula to determine the accumulated balance after the stated period. So using the compound, and always make sure you see the keyword compound interest versus simple interest. You know, simple interest is the first formula, compound interest is that second formula that I gave. And so here, P is 6,000. Your rate is 5% for 10 years, and it's compounded annually. So N is equal to 1. So use that same formula that we just finished using for Derek. $6,000, 1 plus 0.05, compounded annually, raised to the 1 times, I believe it was 10 years. And see, and that one asks you to round to the nearest cent. So like I said, make sure you pay attention to those directions. Compound interest, balance, yep, same thing. Deposit 55 in the savings account. Now notice this doesn't mention compound interest, so they're gonna assume you know simple interest. So $5,500 into a savings account, APR is 1.8%. So if they don't mention anything about compounding annually, semi-annually, anything like that, then it has to be simple interest. And so that's 5,500 times that 1.8%, which would be 0.018 times 1, because your time is 1 year. And so that's all that would be for you. I won't take that away from you. I'll let you play with that. Linear growth. Okay, here, linear growth versus exponential growth. That's a word one. I don't want to do that one for you either. Okay, here, let's do this one. So the population of a town increasing by 603 people per year. State whether the growth is linear or exponential. And then, so before we do that one, I want to show you the difference between a linear and exponential. Notice how it's increasing by 603 people per year. Now this next one is increasing by a rate of 10% per month. So it's a percentage versus a number. So if it's a number, it's going to be linear.
Okay.
All right. And then that means what would the population be in 5 years? We would take that 1,100 and add 603 5 times. Or multiply the 500, multiply 5 by the 603, add it to 1,100. That should be 40. Somebody went out the back door.
When you have the alarm system, you know, you're like, wait a minute.
Right. So is everybody cool with that one? So when it's linear, it's going to be a regular number, and it's going to increase by that number, however many years they add. So once again, it was 5 years. So 5 times 603 was what, 15. Add that to the 1,100, and that's how we got to 4115.
Okay. What if it says exponential or
Man, why is she not gonna let me teach though? I'm just trying to figure why. I don't understand. No,
you know it.
We're gonna do that next. I just want to make sure everybody was good with linear. So,
oh my God.
The next one, how you find? During the worst periods of inflation in a certain country, price of food increase. Oh, also pay attention to whether it increases or decreases. This one increased, so we added 603 5 years. If it was decreasing, we would subtract 603 for 5 years. So that just came to mind. Same thing here. The price of food increased at a rate of 10%. Since it's increasing, we're going to add, but if it was decreasing, we would be subtracting. And like I said, that percentage lets us know it's exponential. So now here is going to increase at a rate of 10% per month. So we're actually going to multiply that 10% times the 150 and then add that to the 150. So I don't want to write that down, I guess so. Hold on. So increase rate of 10%. Was it per year? Per month? If your food bill is 150 in 1 month, how would it be 3 months later? Okay. 10% per month. So 150 to start. So how much after 3 months? So what we should have to do is, first of all, convert that to a decimal. So it's going to be 0.10 or 0.1 times 150, which is going to be 15. Then I add that to the 150, which is 165. All right. Then next month, it'll be 0.1 times the 165, which is 1650. Then I add that 16, take that 165 and add 1650 to it. So that is 181.5. Yep. And then do it one more time because we were doing 3 months. So that's going to be 18, 15. Then we take that 181.5 plus 18, 15. That'd be 199.65. Got me again, round to the nearest dollar. So this one asked us to round to the nearest dollar, so they wanted $200. So once again, pay attention to the directions.
No, yeah.
Because I put
It's
199.
gonna be like that too sometimes.
Yeah.
It'll be round decimal, and I'm like, wait, what? And then I'm like,
Right. I put 199.65 in there, and they marked it wrong or said it was wrong. So,
right.
So make sure you pay attention to the directions, and that's the difference between linear and exponential. Once again, the linear, you just add that number however many times to the amount that you had originally. But then for exponential, you got to do a little bit of work. It's not too much. You guys are math scholars, so I know you
know it.
That part down.
Have to open up a math academy. That's so funny. Well, no, I'm not gonna lie though. Like I think my whole life, I've never been good at math until at least this class with you. I know it bases on the teacher how you learn, and I mean I've grasped something. I've learned at least something. You know what I mean?
Very cool. Right.
Yeah, that's not bad. I mean the grade's not an F. I don't think. You know what I'm saying? Good.
And I think that is it for that. So, yeah, because the next 2 problems are the exact same thing. Switch from linear to exponential. So, yeah. So, that's it for 6-1.
Okay.
Like I said, 6-2, that will be on. Was somebody saying something?
Oh, sorry. I was yawning and saying it was.
Oh, okay. So 6-2 will be on you to do or not to do. I won't hold it against you or look at you sideways if you decide not to do it. That'll be up to you. And then 8182 is what we'll discuss on next class.
Okay.
We'll talk about the concepts, because mainly what you need for those two sections are the concepts, which is statistical, and we'll talk about that. And basically, I got some writing for y'all, some real notes for y'all next class, so that you'll be able to, look at those assignments and look at what they're saying in those assignments and know what they're talking about.
Okay.
Yep. So before we close out today, any questions? Any questions? Like I said, we're gonna stop. And I keep saying 8-2, but it's 8-1 and 8-3.
Okay.
We're gonna stop at 8-3, and then from there, that means next week will be our last day of new material.
Right.
And so from that point forward, it'll be
Crunch
on
time.
you guys to take advantage of that.
Yeah.
And really, the next day that you actually have to come to class would be really that final test.
Right.
So if you're deciding not to come to class, I won't hold it against you. Just know that you need to pay attention to your emails then, because at some point I'm going to have a discussion with the class about what day your final is, but I will shoot that out in the email as well. Yeah. So I'm not going to hold you. I'm not going to hold it against you if you don't show up. Because, if all we're doing is talking, addressing questions, and you don't have any, and you don't really want to, you don't really care about what somebody else has as far as the question is concerned, I'm not going to hold that against you. Just make sure you pay attention to your emails, because I will be communicating to you what the day of our final test will be.
Oh my God, how exciting and nerve-wracking. Yo, what? The fact that we all made it through a little bit. I hope everybody.
Yeah, we almost there.
Yeah. We're not there until those grades are in Canvas, all right? And in SIS, I'm not there until I see,
Right.
So that's my thought process. I'm not there until I see that, But it's cool though. Cool.
Yeah, we'll be all right.
Yeah. I wish I could take class with all of you guys. That'd be cool.
Yeah, that would be neat. Form a sense of community a little bit.
Yeah.
Especially in this type of climate. The more support, the better.
Yeah, especially with COVID rising right now, I don't think that'll be happening anytime soon.
It is? I don't have cable, you guys, so I'm like...
Yeah, that's what they're saying. They say it's rising, and TCC, and I don't know if a state they hadn't talked about going back anyway, so it wasn't like it was in the works, and now we got to shut that plan down. They weren't talking about going back next semester anyway. It's all about their liability stuff,
My sister just got tested for COVID. Thankfully, it came back negative, but she's at college right now, and a part of me is like, come on, Shelby, I hope you're doing the right thing, social distancing, but knowing her, she's not doing that whatsoever.
Well, a lot of people aren't, they still want to, which I understand. I mean,
Yeah.
I get it.
Yeah, it's hard to do. I mean, it's easy to lose, especially when you're a college student, you're young, you're in your prime, you're having fun, and then you throwing a mask for what? Like, you know what I mean?
Yeah. That's how your thought process is. You're like, I don't need this.
You're looking at everybody looks healthy, everybody dancing, everybody jumping, you know what I mean? So
yeah.
It's easy to lose yourself in the moment,
Oh, yeah, I hear that. Like, I shook hands with a neighbor yesterday, and I thought, Lord, I hope I don't get sick.
I went somewhere, and the lady reached in to hug me. I was like, oh no! Like, and she was an older lady, so I was like, we're not supposed to be doing this.
Yeah, oh my God. See, we have those thought processes though. I did, because he reached his hand out, and I was like, damn, all right, like, But I mean, I don't know. And then I got home, and I sanitized everything, and I washed my hands. Oh my God, that's so funny.
I work in home health care, and my client, he always says, he can't even pronounce my name, which I find that funny, but he reaches out his hand every time, it's like, to make me take it, and I'm like, I'm sorry, I'm not doing that while this pandemic's going on. But I'm happy to give you ice cream instead.
That's I don't know. It's just weird, because when you meet someone formally, you're used to being like, "Hey, how you doing?" instead of just being, "Hey, what's up?" Like, I don't know. This whole year is interesting, and I'm looking forward to next year. Hopefully, things will be good.
Yeah. I hope so, because I know when 2019 hit, we were looking forward to 2020. I don't know.
I
I don't know
know.
if anybody remember that. We were
Yes.
2019.
Yes. And it was going really well until
Right.
Kobe Bryant died, and then the whole thing just went down from hill,
Yeah.
in my opinion.
Yeah, it was
We were
pretty
like,
crazy.
yeah, but interesting. I'm glad I got to live through it, because when that history book, when it goes to the history books,
Yep.
your
We
daughter's gonna be like,
tell,
what's this?
tell our
You know?
grandkids about it.
Yeah, it's interesting. Everyone went
Yeah.
crazy for toilet paper. I don't know what it is, but like,
Yeah, what's the whole entire point of that? Like,
I don't either. But I mean, I felt the same. I was like, damn, I need it, because I don't know.
Right. You just never know.
Yeah, I don't know. Everybody made me nervous, and I was like, I guess I'll stock up on toilet paper and shit. I was good for like the whole year.
Right.
So, but I think it just made me learn a little bit to be not stocked, but a little backs off, like have 2 of everything maybe, so you don't have to go out again.
Yeah.
Yeah, I did the same thing.
Yeah, like, so it was, I mean, I learned a lot, I guess, this year, but yeah, still crazy and stressful for everybody, I'm sure.
Right. Well, I guess we're gonna end on that type of note. Pick it back up. Yay. But outside of that, guys, you guys have a good one.
You too.
And I will see you on Wednesday. Looking to close out.
Yeah.
Yeah.
All right, you guys. See
All
you
right.
later.
have a
Bye,
good one, y'all.
guys.
You too.
All right, have a good one.
Bye.
Here.